Good day. We are carrying on with the math of equilibrium. This is a booklet that you should have and has 4 pages. The first 3 are showing calculations when we first reach equilibrium, then some stresses are applied to it. And then the last page is where we put together a graph. And from that, hopefully the graph will make sense. And if you see a graph, you can interpret it, or if you have data, you can make a graph. So when we look at this question here, the first page is all about getting to equilibrium, and we are told that we have a KQ value. We're told we have a starting concentration, and obviously you can see it's a nice situation. We're going from not being at equilibrium to equilibrium, and the equilibrium has to be going to right as we make products. So when we look at this, we know we're going to have some minus x, and plus 2x, respecting the coefficients. And at equilibrium, we arrive here with the 0.500 minus x in 2 locations and 2x there. Then we write out the KEQ expression, and we can then solve for x. This is one of those perfect squares. This term is squared and this is squared. And the number doesn't have to be a perfect square. We're just going to take a square root of it. So that's what's going to happen next. So square root of 160 is 12.65, 2x, 0.05 minus x, and now we just go through the algebra, copy as you go, and boom, now we're going to multiply through, we've done that, and now we're going to solve for x, and when we get there we see x is 0.0432 molar, so that's what the H2 and the I2 will drop by, and then it'll be double that for the increase for the HI. So we can get the HI concentration and the H2 and the I2 are equal, and these blue numbers will be important when we get to the last page and we're actually doing the graph. So hopefully you had time to copy it. If not, pause it. Now the second thing we go through is we have a stress, and the stress is an increase in HI. And that is not the change, that's not the shift, that is the stress. And so the stress has already happened. So we have 0.0864 plus 0.0500, and since this has gone up, we know the equilibrium will shift to the left, and these guys will increase somewhat, and this will decrease somewhat. So this time it's plus x, and minus 2x. And we put it all together. This number came from adding those two together. And we go through the same process. KQ, we substitute in these values, take the square root of both sides. The KQ is still 160 because we have not changed the temperature. So we do the same thing. There's our 12.65, and we're going to solve for x. And we come along, and we do that. And we do that, and we gather like terms, and our x is 0.00344, big M, and then we go back and apply this number in here and get our equilibrium concentrations. So the HI is 0.1295, the other is 0.0102, and so we see yes, this did drop, and yes, these went up. Alrighty. Now the third one is a temperature change. And the temperature is changed to 700 Kelvin. So the new equilibrium constant, we're told, is 54. So we have to figure out the direction of the shift. Well, we can see it used to be 160, it's gone to 54. So the shift has to have been to the left. And so we have our equilibrium concentrations. Those are our answers to B. And we go boom, since it's gone left, the plus x, and minus 2x. And so what we do see is the reverse reaction was indeed endothermic. The forward reaction was exothermic. We go through the exact same kind of calculations. Boom, 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 boom. Now we write in our KQ expression. That hasn't changed. but our KQ has changed. But once we have this, it's the same setup. We take the square root of both sides, and now we have 7.35, and we go through the same series of calculations, bringing things together, expanding them out, gathering like terms, and solving for x, and then substituting x back into these locations. So this side we're going to be adding the 0.00583, and this side will be subtracting twice that amount. And we arrive at these concentrations. So we're going to stop the video here, and the next video will show the graphing of the data from parts A, B, and C.